Hey, good afternoon, YouTube. Today what we're going to do is 2016 AB2 on Sage. Okay, so for t greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t, and the position of the particle is x equals 2 at time t equals 4. In other words, x of 4 equals 2. At time t equals 4, is the particle speeding up or speeding down? Now remember, if the velocity is positive and the acceleration is negative, slowing down. If the velocity is negative and the acceleration is positive, it's also slowing down. Okay, so, hang on. Whoa, where did my question go? There it is. So, let's go into a Sage cell. Alright, and let's put a little comment with your name and the date. And the topic, 2016 free response AB2. Okay. All right, so for 2A, let's define V of t is, now it's given, what is it? 1 plus 2 times the sine of, don't forget times is explicit, you got to type it, t squared over 2. Remember, sine is already in radian mode in Sage. And t squared over 2, it's going to square before it divides. Please excuse my dear unsolidated order of operations, that's fine. And then a of t is going to be the derivative, dv dt is going to be the derivative of v with respect to t. So how about the diff of v of t with respect to t? Okay, and then let's show v of t, make sure that we entered everything correctly. And let's show a of t. And click evaluate. And we get, there's v of t and there is a of t. And of course a of t you could have done easily with the chain rule without Sage, but there it is. Now I don't want v of t and a of t, I want v of 4 and a of 4. See if they're different signs, right? It's slowing down if there's different signs. So v of 4 and t of 4. Why is it doing that? This keyboard is weird. Okay, t of 4. And evaluate that. Yeah, but who knows if those are positive or negative. Okay, so let's throw in a, how about dot n? Dot n here, and dot n here to change it into numerical with decimal value. And get rid of this, and evaluate. And we get V is yellow. Slow network today, sorry. V is, come on, V, let's go. Oh, did I lose the network connection? Okay, I'm just going to highlight this whole mess. Let's see, highlight this whole mess. Dang it. Why is it stuck? Hang on, sorry, technical difficulties here. Can I highlight this whole mess? And copy it in case I have to restart this whole thing. Did I do it? No. Okay, so this is what I'm going to do. I'm going to reload this page. And then I'm going to paste. Whoopsie, what happened there? Wrong site. Okay, this is very interesting. Okay. There it is. Okay, good. And now let's evaluate. Hey, come on. There you go. So V is positive and A is negative, so slowing down. That's the answer. Okay, so slowing down. Particle is slowing down, right? You should write a whole sentence, right? The particle is slowing down because the velocity is positive and acceleration is negative. All right, write a little sentence there. Perfect. All right, what's 2B? All right, let's find out. Why is it not staying there? Okay, 2B. Find all times t on the interval from 0 to 3 and the particle changes direction. Justify your answer. All right, so in other words, does v of t change sign? Is v of t ever 0 from 0 to 3? Oh, okay. Well, why don't we graph this and see what it looks like first? Now, this is a periodic function with sine of t squared over 2 in it, right? So it can have a lot of zeros. So I want to focus on 0 to 3. So instead of doing the solve command, that'll give me a million different zeros, I'm going to use the find root command. That doesn't give me exact answers, give me numeric answers, like using something like Newton's method. But I can specify between 0 and 3 if I want to, so there you go. Excuse me. So let's plot v of t from 0 to 3 to see if there is a 0 in there somewhere. And so x min is 0 and x max is 3. Wow, this is really slow connection today. Yes. Do I have to do this again? Well, why is this acting so weird today? The network is really acting stupid today. Did we get it yet? No. Okay, so this is what I'm going to do. I'm going to reload this. I'm going to paste what we had and reevaluate it. Yay. Our network is acting up today. There you go. So, all right, so look, there you go. So there is a 0 around 2.7-ish. I don't know what it is exactly, but somewhere around 2.7-ish, right? All right, so to save paper, we don't put a show on the plots so that when we do other shows afterwards, it goes away. So the plot's going to go away. But let's not use the solve command and then enify it like we usually do. Let's use the find root command where we can specify where it's looking for the root, and it's going to give me a numerical answer, not an exact answer, right? So how about show find root of v of t. When is it equal 0? Remember, equal is a Boolean. It's either true or false. Find root is trying to find a t that makes it true. Now you don't have to say comma t like you do in the solve command. It's assuming the variable. But from 0 to 3 is all it's going to look. Okay, so let's show that root. And the root is. Why did it get stuck there? Why is it? Well, I'm sorry. This network is getting really clunky today. I have to do this every single time. Are you serious? Oh boy. Copy this. Get out of here. If I just click it really quick again. Nope. I lost it. Alright. Reload. Control V it. Try it again. Wake up to the internet connection to our server in Washington State. There it goes. Yeah, so it is around 2.7. It's 2.707. Now, if you take a look ahead, all right, so I'm going to say, how about changes direction at about t equals 2.707. There aren't any units here, so don't say seconds or anything. Okay, now take a look at the rest of the question. And you should write a sentence because v is positive before that and v is negative after that. And this this is an x of t, right, that we're dealing with. It's moving left to right. So v is positive is moving to the right, v is negative is moving to the left. But if you take a look at the rest of the question, why doesn't it stay? Down here we're going to need the total distance it travels. We're going to need that root because think about it. We're going to take the area from 0 to that root and then change the sign of the area from the root to 3 because it's negative. I want the total distance, not the net displacement, right? So when I do the integral here, I'm going to need to know what that root is, right? So I'm going to store it. How about we do this instead? Let me store that root. I'm going to say, all right, instead of showing it here, I'm going to say root equals that number. And then I'll show the root so I can still see it here. Oh gosh, please work. Is it going to do that again? Wow, this has not been this pesky in a long time. This is my network, my Wi-Fi network at school. Sorry guys. I really have no control over this. Alright, so I'll copy this. Wow. Does evaluate help at all? No. Okay, reload this page and then paste it, and reevaluate should open up a new internet connection to the server. There you go. And is the root still 2.707? Come on, you can do it. Ugh, why is it stuck? Wow, it's really stuck at that point? You did the first 2 shows and you can't do the 3rd show, really? Ugh, gosh. So sorry. I'm trying to do this on my tablet and it's acting up. It's not the tablet, it's the Wi-Fi in the school connected to the tablet. Come on. Wake up. Wake up. Aha, there it is. Okay, good, perfect. Now, 2C. Find the position of the particle at t equals 0. Well, remember, v of t is really dx dt. So if we integrate this from, say, from 0 to 4, right? We're talking about t equals 0 and t equals 4. We know what happens at t equals 4. We're trying to figure out what happens at t equals 0. So we know x of 4 is 2. We're trying to get x of 0 is what, right? So if we integrate the velocity from 0 to 4, don't we get x of 4 minus x of 0? How do you get x of 0? You're going to subtract, let's see, if the integral is x of 4 minus x of 0, transpose, and x of 0 is the integral minus x of 4. Hang on. Transpose, and we're going to take x of 0 to the left side and the integral to the left side, so it's x of 2 minus the integral, or in other words, 2 minus x of 2. 2 minus the integral, right? So where did I put that? Where is it? There it is. Okay, so let's write that. Okay, so let's see. So in part C, we're simply going to show x of 4, which is 2, minus the integral from 0 to 4, which will give us x of 0. So how about, let's use a numerical integral. Instead of integrate gives me an exact answer, then I have to nify it. Sometimes that's a problem. I just need a numerical integral. There you go. Of, well, v of t. Now, with integrate, you have to say comma t. But here, I'm not. I'm just going to say from 0 to 4. Let's see. All right, so let's see what that is. Oh, don't crash on me now. Why does it always get stuck on show root? Now, last time I did this already. I got negative 3.815 for x of 0. Because we have x of 4 minus the integral from 0 to 4. That's x of 0, and it's stuck again. Here we go. Let's play the game. I apologize. This usually doesn't happen. Copy. Then, is this going anywhere? No. Whoopsie. Okay, load. And let's put that in there, and let's evaluate that. Ooh, what'd I do? I did something weird here. Show 2 minus the numerical integral of v of t from 0 to 4. What am I forgetting? I'm forgetting something silly. What am I forgetting? Alright, let's simplify this a little bit. Alright, let's get rid of the show and the 2 and everything. Let's just get the numerical integral part working. All right, try that. There it is. So why doesn't the show work? Oh, I know. Show. If you show that, look what you get. Oh, don't get stuck now. Oh boy. Wow. Ugh. Okay. Right, the problem is this. If the numerical integral doesn't return a number, it returns a list. Look what you get. Yeah, man, you can do it. No, this is taking forever today. What is going on? Oh boy, we're playing the game all day. Come on, wake up. This is supposed to be a short. This is taking all day. Okay, you know what? To save time, you know what I'm going to do? I'm going to comment this out so it doesn't have to recalculate this every time. Comment this out and comment this out. So it just does this one show, okay? Because this is driving me crazy. So just go to the one output that I want. So it's only going to have one show, right? Yeah. So do it. There it is. All right. So this sort of, it does something like Simpson's rule where this is the area and this is an overestimate to the error. Look how good it is. E times 10 to the negative 14th. Move the decimal 14 to the left. You got so many 13 zeros of errors, no errors. Great. This is perfect, okay? All right, so that's what I'm subtracting from 2, though, right? So I don't want this. So since it's a list, I can tell it just to give me the first element of the list. I can say sub 0 is sub 1 for the first or the second element. I want sub 0. And let's see if we can just evaluate this much. Yeah, man. Wow, here we go again. La 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 la. Did it do it? No. Sorry, I'm trying to show you how great Sage is for this, and it's looking terrible, but it doesn't usually do this with the Wi-Fi. All right, so now I want to subtract that from 2, right? So that's the area from 0 to 4. If I subtract that from x sub 4, so which was 2, then we're in business. All right, can we get away with this? And I think I got negative 3.815. Okay, there you go. So let's write down that answer. Okay, what is it now? We got x sub 0 is about negative 3.815. I don't have a decent symbol for about, but there you go. All right, so let's do 2D. Holy moly. And let's see what 2D is. Come on, 2D. And stay in the file. All right, find the total distance a particle travels from 0 to 3. Now, we're going to do the integral of v of t. How about the numerical integral again? From 0 to root minus the numerical integral of v of t from root to 3, because we want the absolute value of all the integral, all the definite integrals where you have negative areas. So we take the absolute value by subtracting the negative piece. Remember the graph? It went below the t-axis after the root. Aha. All right, so that's what we're going to do. So let's show. All right, let's do a show of the numerical integral of v of t from 0 to root. Remember, we stored root already. Root was about 2.707, right? Wrote that down someplace, didn't we? Yeah, we did. Okay. root. Okay, now don't forget, this returns a list. I don't want the list, I want the 0th element of that list. Okay, and we're going to subtract from it the numerical integral of v of t from root to 3. And remember, you don't have to say with comma t with respect to t, right? And again, I want the numerical estimate. There you go. And hopefully I don't have to reload this whole mess. Come on, calculate. Alright, I messed up again. Or the Wi-Fi messed up again. Alright, let's copy all of this. Let's copy all of this. Did it do it? No. Let's reload this. Wow. Sorry, I don't usually have to do all this reloading stuff. This is crazy. And evaluate that. I got the last two shows. Should be the negative 3.815. And I think the last time I did this, did I get an answer for part D? I don't have the answer for part D right here. Okay, let's find out what it is. Okay, 12 is slowing it down. All right, so let's line 12. Let's go to line 12, comment it out, because our internet is ridiculous today. So I can't do more than one calculation at a time. Oh my God, this never happens. Right, okay, so reload. Go ahead, load. All right, and then Control V to paste. And it's only going to do the last show, hopefully. There it is, 5.301. Okay, so the total distance traveled. Let's say D is about 5.301. There you go, perfect, done. I wish I could show you all the outputs at the same time, but the Wi-Fi is really not being cooperative. But you got it in the video. All right, that's it for today. 2016 AB2 using Sage and my tablet. And that's it. And this supposedly is short, but I don't know how short this is. All right, bye-bye, YouTube.